Hey everyone. Alright, so we're going to make this screw on the lathe with some live tooling. So this is how you should receive the file. Should already have the machine group and the planes. Everything's pretty much ready to go. So we're going to start out with 1 3/4 round stock. We're going to turn it down. We're going to make a thread, and then we'll machine the flats, and then we're going to put some engraving on each flat. So let's get started. So I'm going to go ahead and set up my stock. Stock setup. Go to properties. OD 1.75. Length, I'm just going to put 6. And use margins, right margin 10 thousandths. Green check. Chuck jaws. And go to parameters, and from stock, grip on max diameter, grip length, say 4 inches. So green check on those. That basically gives us a little bit of room. Let's see, our part is 1.5 inches long. Okay, so got our stock set up. So now we can start with we'll face it, we'll turn it, and then we'll get in and we'll thread it, and then we'll get into the live tools. So face, so 500 surface speed, 3000 max spindle RPM. And I'll go with 7 thousandths on the feed rate. I'm going to overcut it. Alright, green check that. And go ahead with a rough. So I'm going to start here. End is right there. And then I'll go ahead and extend it past there in the settings. Use the same tool. I'll go 25 thousandths cut, leaving 10 in X, 5 in Z, and then I'll go to my lead in, lead out, and under my lead out I'm going to extend it. Let's try 150. Check. And I'm going to, for stock recognition, I'm going to use stock for outer boundary. Green check. Alright, not quite enough. It's like we got to the back of the part there pretty much, so I want to extend it a little more, so when we go and cut it off. So let's go back to, go back to our parameters. Lead in, lead out, and we'll go 0.3. Green check, green check. And there we go. Alright, so now we can go ahead with a finish pass. And here, under the selection, I can use the last selection. Green check on that. And we're going to want to use our finishing tool. I'm going to call it tool 3. Okay, 5,000 feed rate seems good. 500 surface speed. 3,000 max RPM. Alright, finish. It's going to be one finish pass. Lead in, lead out. Let's see. Since we're going to do the chamfer there on the front, I'm going to give it a lead in like this direction. And I'll just extend it like 50 thousandths. For my lead out, I'm going to extend it 0.3, just like the roughing. And that should be good. Green check, green check. Go ahead and save it. Alright, so I'm going to go ahead and hide these tool paths. Oops. Right there. I'm going to go ahead and do a little thread relief before we put the threads in. So I'm going to go to wireframe. I'm going to create a point. So I'm going to get my plane set up first. Plus D plus Z. Plus D plus Z gets the C and the T. And then I'm going to go to wireframe, create a point, and my position is going to be diameter 1.5, comma, my Z is going to be minus 0.63. And green check that. And then I'll go to my turning. And I'm going to go to the cutoff toolpath. Select cutoff boundary point. So I'm going to click that point that I just created. I'm going to choose this one here. I'm going to change that to tool probably 5. Alright. Okay. Coolant's on. So we should have coolant on all drill paths. Let's see. Cutoff parameters. So I'm going to set the X tangent point. So obviously I don't want to cut the whole part off, right? I'm just going to come down to a certain dimension to make my thread relief. So my X tangent point is going to be 0.9. And that should be it for that. So green check. What's going on? It wants a radial number, not a diameter. So change the cutoff point to 0.45. It's basically going to be like a 1-inch thread. So Okay, so I wanted to send it to a diameter 900, but it looks like the toolpath wants a radial value, so we put 450. Alright, let's go ahead and put this thread in. So I'm going to choose thread on the toolpath, so I'm going to choose this OD thread right tool, and I'm probably going to call that tool 7 because my previous tool was 5, so tool 7. Alright, and then let's see, I'm not going to mess with any of this stuff right now. Coolant's on, just make sure your coolant's on. I'm going to go to thread shape parameters. I'm going to go select from table, and we're going to do a 1" 12. So scroll down, 1" 12 right there. Okay, green check, and we come back here and see it adjusted our feed rate for us. Okay, so this is all good. Major diameter 1", minor 9. Okay, and so start position is 0. End position is going to be actually select that and put it on there. And let's say minus 0.74. Alright, we want, in our thread cut parameters, we want to use can cycle. This is why it's important that you use the Haas machine, because if you just use lathe default, you won't get the right threading can cycle. So make sure you use that file that I gave you. So we don't really need to mess with any of this. Hit the green check. And there we go. We got our threads. Now we can move on to the good stuff. I'm going to minimize these toolpaths. Save. Alright, so the next thing we need to do is cut the flats. Okay, we're going to need some geometry since we have this little chamfer here. We don't really have a straight line that we can have the tool follow, so we're going to need to just go ahead and draw those in. So I'm going to go to wireframe and line endpoints, and I'm just going to go from the center of this one to the center of that flat, and just keep going around each face. Alright, green check that. Okay. Things are still good. Alright, so now I have the wireframe going all the way around. So I'm going back to my turning toolpaths, and I'm going to go with face contour. Okay, I'm going to use wireframe chaining because I just drew the wireframe. And I'm going to go with a chain. So I'm going to click on the first line, and it should go all the way around, just like that. Green check. Alright, for my tool, I'm going to use a 1/2" flat end mill. I'm going to call that tool 8. Let's see, spindle speed. Okay. Just gave us that warning because there's like no speed and feed here. So for the spindle speed, I'm going to go with 2500 RPM. A lot of live tools max out at that RPM, so maybe able to go up to 3000 with ours. For the feed rate, we'll go 20 inches per minute, 2,000 chip load. And for our plunge rate, we'll go 10 inches a minute. Okay, all looks good. Cut parameters. Should be using wear compensation. And we should be using left. Alright, for climb milling. Stock lead on wall 0. Depth cuts no. Yeah, lead in, lead out. We do want that. So 40, 40, 60. Alright, multi passes. I might make a couple passes on this. So I'll probably go with 3 roughing passes, 50 thousandths. Do 1 at 10 thousandths. And maybe 1 spring pass. Okay, linking parameters. I change everything to absolute. For the depth, we'll go back here to minus 1.5. Coolant is on. Green check. See what that looks like. Oh, very nice. Okay. Save it. Let's go ahead and just verify it real quick. Alright. Now the verify is going to look a little bit weird because of the threading tool. It's like, for whatever reason, Mastercam puts the origin of the tool at like the center, at the point of the tool, and we always set it at the front of the tool. So that's why it looks like the threading tool went too far, but it'll be fine on our real part. You can change the depth, you know, in your program if you want to see a better verify, but just know that it's going to be fine with the numbers that we have. Alright, so close that. Alright, so now we're going to do some engraving on the flats. So the first thing we'll have to do is put something to engrave on there. Alright, so to make some wireframe, I'm going to go ahead and just create a plane on the surface from solid face, and I'm just going to go ahead and make the X go to the right side. Alright, I'm going to go ahead and green check that, make it current. Right click top, and then I'm going to go to wireframe, create letters, and I think the first thing that we'll do is probably Laney College. Oops, caps lock. Laney College. Probably want my height to be about 0.1. Let's see if that fits. It's pretty close, should be fine. Just gonna, let's see, can I see if we can make it more centered. Okay. So I put a space in front of the L for Laney, get it a little more centered. Alright, I'm just going to kind of place it there in the center, and green check. Alright, and then I'm going to go ahead and I'm going to do that on the next face. Excuse me. So planes plus from solid face, and then I'm going to go to this face. Make sure the X goes to the right. It's not really for machining, it's just to get the letters oriented properly. So green check, make that plane current. And the next thing I'm gonna write is wireframe letters, and I'm gonna do MACH32. So if you hold your mouse and rotate the model a little bit, it'll make that preview kind of pop up for the engraving. So do a right click top. I can get there and sort of center that. Just like that. Alright, green check. Next face. Make the plane current. For this face, I'm going to put the date, but I'm going to do it a little different. You'll actually see this a lot. It's the week number. So usually what you get is a 4-digit number for the week and the year. So the week of October 22nd happens to be the 43rd week of the year. So it would be 4-3 for the week and 2-3 for 2023. Alright, right click top, and I'm going to kind of center that right there, just like that. Okay, so Laney College, Machine 32, 4323. Got 3 more faces. So the next one, I'm going to go planes, from solid face, just like that. Make it current. Right click top. This one I'll put my initials. So frame ELL. Again, if you rotate the model a little bit and then click top, you can get the preview so you can place your text a little better. Like that. Green check. Alright, next plane here. Set that, green check. Let's see, for this one I'll go ahead and type in the size of the thread, 1 inch -12. Green check. Alright, let's see. For this last face, I'm going to show you guys the serialization. So for this part, we're just going to do our letters, and we're just going to do 0001. Right there. Okay. Got all of our engraving. Let's go back to our standard top plane plus D plus Z, and we'll start our engraving. Alright, so you have two options here. You have a C-axis contour and you have a cross contour. Now, the C-axis contour is fine if you're doing like something around the OD, or if you don't have a Y-axis, because it's more difficult because it can't get off center line, right? So the cross contour is good if you have a Y-axis like we do, so then you can get a nice even contour. So we'll choose that one, cross contour, and then we're going to use the window for our selection. So I'm going to rotate it around a little bit and select like that. Sketch approximate start point. Just click on somewhere on one of the letters for a starting point, and green check. Quick little note about window selection. You can see how I have the model kind of rotated a little bit. So when you make your window, a couple things you have to keep in mind. One is that everything within the window is going to be selected. Now if a portion of the geometry is slightly outside the window, like right now, if I was to click, see, it wouldn't grab the entire E. So whatever you select has to be completely within the window. The other thing is, when you create the window, you have to imagine the window as kind of projecting itself through the screen, and whatever's behind it will also be selected. So what that means is if you have the model rotated something like this and you make your window, not only are you going to get the Laney College text, but if you rotate, you'll see you also got the stuff down here at the bottom of the part on the other face. Okay, so that's why kind of rotate it, rotate the model so that when you make your window, you're only getting the geometry on that face. Okay, so the way to fix that would be to right click in here, rechain all, get your model rotated so that it won't select anything but what you want. Got your window selection, come back here and make your selection like that. Okay, again, watch out that you don't select this straight line right here that we used for, to make the hex. Make sure you don't get that in your window because you don't want to engrave that either. Okay, back to the video. For our tool, we'll go ahead and grab a 1/32 ball end mill. And I'm going to call that tool 10. Go 3,000 RPMs. Go 5 inches a minute. And 5 on the plunge. And just like our engraving on a mill, compensation is going to be off. 2D. Everything here should be zeros. No depth cuts, no lead in, lead out, none of this stuff here. Linking parameters. We're going to do clearance. Clearance of 1 inch, but that's only going to be at the start and end of the operation, so that way when it rotates to the next face, it'll have a nice clearance. So check this one here. Use clearance only at the start and end. Retract 0.1, feed plane 0.05, and depth minus 0.003. Make sure your planes are correct. Again, top is your WCS, and your tool and construction plane is the plus D plus Z. Coolant is on. Oh wait, real quick before we green check. Axis control, you'll see Y-axis, right? Green check. And there we go. Alright, so I'm going to do the same thing with the next face. Everything should be the same. Alright, shouldn't really have to change anything. Recheck. Seems like it's retracting to the clearance plane at too many spots, but we'll see what happens. And we're just going to continue on each face around. Alright, so for the last face for the serial number, we're going to do like before, but we're going to on my tool parameters, I'm going to go with a force tool change, because we're actually going to edit that code in class. We're going to do the serialization macro. So everything else will be the same, and we'll show you how to do that in class. Okay, so that's that for that. So if we save it and then we do a verify, so we have our engraving all the way around. Looks good. Alright, so one more thing, we got to cut the part off. So hide all these tool paths. I'm going to come in with another cutoff toolpath. Boundary point is going to be right there. Same tool as before. My entry amount is going to be 250. Green check. And there we go. Now if you want, If you're planning to, you know, flip this over, put it back in the lathe and face it off, then you could come back in here and leave some back face stock. Or if you're just gonna hit it on a belt sander to take off that nipple, then you're done. Okay, so that's that. Turn in the Mastercam file for this. We'll see you on the next one. Alright, so this is going to be a little addendum to the screw video. I'm going to clean some things up and incorporate some lessons learned from the first few parts that we run. So the first thing we're going to do is update the tool numbers. So yeah, once we set it up, the live tools and the regular tools got to go in specific positions. So first thing I'm going to do is the roughing tool. That becomes tool number 4. So I'll go to the parameters and change this to 4. Green check. Alright. Yes, continue. Go to my next toolpath, make sure that my tool number updated. It did. And our finish tool becomes tool number 2. Cutoff is tool number 6. Threading tool. Is tool number 8. Alright, our 1/2 inch end mill. Comes tool number 9. And our ball end mill, the 90-degree. I'm going to double click on that and I'm going to come here. It becomes tool 11. And then this pop-up is what you're looking for, and you want to update on all the operations that use that tool. So green check, and okay, green check. And so the rest of our, you want to make sure you get 11 on your tool number, your length offset, and your diameter offset. That way you don't run into issues. Okay. And then the part off tool should have been changed to number 6 already. Okay, so that's good. Save that. So the next thing we noticed was that the threads were coming out a little bit rough, so we're going to rerun the finish pass and then the thread. So I'm going to hold the control key, select toolpath number 3 and number 5, then I'm going to hold the right mouse button, drag it down, release the mouse button, and I'm going to select copy after. Okay. Regenerate. Save that. Alright, so the next thing we noticed was that the flats, when we machine those with the live tool, they're a little rough, a little wavy. So if we go into that toolpath, number 8, and if we go to arc filter tolerance, and we're going to come over here, we're going to activate smoothing settings and activate use fixed segment length, and we're going to change the 20 thousandths to 5 thousandths. And that's going to give us a more precise rotation on our C-axis, and it's going to make the flats look a lot better. So green check that. The other thing we can do is on our cutoff operation, there's actually functionality to add this chamfer in. So we'll go ahead and do that now. Let's see, what I need to know is this diameter, 1.5877. What I need to do is I'm going to need to move this point here to that diameter, and that's going to allow me to get the chamfer that I need. What I'm going to need to know is how big is the chamfer. So top diameter is 1.5877. This diameter is 1.325. So if you subtract 1.5877 from 1.325, you're going to get about 0.262. Divide that in half because we're talking diameters. It's going to be about 131 is the size of that chamfer. So the first thing is I'm going to make a window so I can grab that little point, and I'm going to go analyze entity and diameter 1.325. I'm going to change that to 1.5877. Green check. And then I'm going to come to my toolpath parameters. One thing we need to change is this max spindle speed. I guess I missed that in the original video, but yeah, you don't want your part spinning 3,000 RPMs when you part it off. So I'm going to change that to a max RPM of 500. And then in the cutoff parameters, so one thing we could do if we wanted to was we could put a number here in the X tangent point like we did for the thread relief, just to get it close to the center so the part actually doesn't fall off and you have to find it in the machine. So that's one option. I'm not choosing to do that. But to make the chamfer, we come over here to corner geometry and we select chamfer. And then we're going to select parameters, and so we said our chamfer is 0.131. Now if you had some wireframe geometry that you had created by using turn profile in the wireframe section, then you'd be able to use this select chamfer line. We didn't do that though, so we just did the math. It's 131, angle's 45 degrees. These values here, top and bottom radius, they'll put a little little radius on the corner there so you don't get a sharp corner, which is nice. So I'm going to green check that and green check that. Now you're going to have a collision. So the problem is, if your tool just comes in to do the chamfer, now this part of your tool is running into material over here. Okay, so what we do is go back to the parameters and we activate clearance cut. So the clearance cut is going to bring the tool straight down first and then come over here and do the chamfer. So clearance cut. I'm going to choose from stock. So my X increment is 5.1. And a Z increment I'm going to change that to 10 thousandths. Green check and green check, and now you see no errors. And if we do back plot, we'll watch the tool. So first it's going to come down, clear out some room, and then it'll come over. Come on, do the chamfer, and then come down and part it off. Okay, I'll go ahead and save that. Alright, so I'm going to hide that toolpath, save it real quick. Now, when we created all of our lettering for the engraving, actually not created the lettering, but created the toolpaths. So when we created the toolpaths, the face contour and the cross contours, Mastercam in the planes section, if you look there, Mastercam created these planes: lathe upper left top and cross upper left top. So if you remember from the mill 3+2 stuff that we did, that's how Mastercam controls rotation, and keeps track of which face is where. So that's all fine. The problem for us is if we leave things as they are, we're going to get a bunch of different work offsets posted out when we post our code out. So we don't want that. We want everything to post out to G54. So we just have to set up one work offset. So to fix that, we just need to go into these planes that Mastercam created for us and force them to post out to G54. So I'm going to highlight lathe upper left top, hit the equal sign to make it current, and I'm going to change it to manual work offset and 0 for G54, and it's going to, I'll press enter right after I type in 0, then this pop-up should come up, and I'm just going to say yes. I'll do the same thing with the cross upper left parentheses top, hit the equal sign, make it current, manual and 0, enter. It says 6 operations use this plane. Yes, I want to update everything. It's saying you've already used that work offset. Yeah, it's okay. I'm fine with it. Check. Alright, so that's going to solve our posting issues. So save it. And then when I go back to my toolpaths, you see they became dirty, so I'm just going to regenerate all dirty operations and save it. So now when I post out, I should get only G54s. G54, G54. Alright. Alright, so the last thing that we found out was that the lathe cannot do the serialization engraving like the mills do. So if you're going to do serial numbers on these parts on a live tooling with the lathe, you're going to need to create a separate G-code file for each serial number, unfortunately, or you could just put it on the mill and use the macro. So what I decided to do instead is I'm just gonna go ahead and put the Laney Eagle on that face. So my planes back to top, and C and T, get the plus D plus Z, and right click top. So I'm gonna go and hit actually, first thing I'll do is delete that right there. So select those. Again, watch your window selection. But anyways, I'm going to delete those. I'll get the message, hey, these numbers are tied to a toolpath. Are you sure you want to delete them? Yes, I do. Okay, so you see my toolpath went dirty. And once I add the logo, then I'll just reselect the geometry and I'll be good to go. So now I need to merge in that geometry. So File, Merge, Laney Eagles, DXF, green check. Obviously it's a little large, so we'll go in and we'll scale that down. So I'll go to my levels, and looks like level 3 now has got the eagle on it. So I'm going to make that my active level, and I'm going to hide level 1, so that way I only select this here. So window selection, and then I'll go transform scale, and I'm going to scale it to a factor of 0.125, so 1/8 size. And I want to select move, not copy. Alright, so move and 0.125 scale, green check, and I get the little warning. One of the lines must have gotten too small. It's no big deal. Hit OK. Okay, and then now I'm going to transform, translate. I'm going to move from to. So from origin, and the 2 is going to be back on my level 1, so go to levels, level 1, and select right there. Alright, so now you got to go, make sure you go back to the translate thing here and hit the green check. Otherwise your eagle will mysteriously go back to the origin, and you might not know why. Alright, so I'm going to go ahead and rename this level here to Eagle. And I got this level here, level 2, with no entities on it. So I'm going to clean that up. I'm going to right click, and I'll say clear empty levels all. Okay. So now we still have to rotate the eagle to this face, but also I mean, we could leave it like that, but I want to rotate it 90 degrees. I think it would fit better on the flat that way. So I'll just go ahead and hide that again, and select and transform, rotate. I'm going to want 90 degrees, and I'm going to want to click on the rotation thing and move it over here to the center, and that way it rotates it about that point instead of this one over here. So green check that. Clear colors. Let's bring this model back, and okay, I like that. To me that looks a lot better. Alright, so now remember that, you know, rotation happens in the XY plane for Mastercam. So if we want to rotate from this face to this face, we need a plane that has the XY on sort of this front plane, right, where the Z would be coming straight out. So what we can do is we'll go to our planes, and it should be the right plane. Yeah, that's the one we want. So if I do a right click top, so now I'm in this orientation, and my rotation will be around like this, because that's the XY plane in this coordinate system. Okay, so levels, I'm gonna hide everything except for the eagle. Windows select, transform, rotate, and this time it's going to be 60 degrees. Okay, and green check, make sure it's move, not copy. 60 degrees, green check, and bring back our model. Okay, that's on the right face, everything looks good. So I'm going to go back to my top plane, and plus D plus Z gets the C and the T. And my toolpath, so my toolpath that was still had the serial number. So now I'm going to go into the geometry for that one, and I'm going to do a right click, rechain all, get my window selection. Oops. That should be good. Approximate start point, I'll just click something over here. And green check, regenerate, and save. Now when you merge two files together, it thinks you might want to change the name of your file. You know, this is why this pops up instead of normally when you hit save, it just saves it. So make that decision, and then that should be good. Highlight everything, do a verify. Again, verify without the cutoff so we can actually see it. Alright. Okay, looks good. So that's that. Hope you enjoyed it.